On note card number 5, we also covered scientific notation. For scientific notation, you need to be aware that the first number has to be a number that is greater than or equal to 1, but less than 10. The base is always going to be 10. And the exponent on the 10 is going to determine the number of places that the decimal must be moved. If it's negative, you're going to move to the left. If it's positive, you're going to move to the right. Okay, if we have an equation that asks us to simplify 3.24 times 10 to the 9th divided by 1.2 times 10 to the 5th, and all of that is squared, they're asking us to write it in scientific notation. Okay, first we're going to do inside the parentheses. We're going to use PEMDAS, so solve inside parentheses first and then do exponents. So we divide 3.24 by 1.2 and we get 2.7. Using our quotient of a power property, we have 10 to the 9th divided by 10 to the 5th. So 9 minus 5 is 4, so it's 10 to the 4th power. We still have to square the entire expression. So 2.7 squared is 7.29. 10 to the 4th squared would be using the power of a power property, which gives us 4 times 2, which is 8. The 8 means to move 8 decimal places to the right. We have a base of 10, so we know that we have scientific notation. And the number 7.29 is greater than or equal to 1 and is less than 10. If we were to actually write this number out, 7.29 times 10 to the 8th power would be 729 million. On note card number 6, we covered function and function notation. A relation is a set of ordered pairs, x, y. A domain is the entire set of x coordinates. The range is the entire set of y coordinates. A function is a relation such that no two pairs have the same x coordinates. In the table provided here, the domain would be -5, 0, 3, 7. We abbreviate domain with the letter D, and we write it as a set with braces on the outside and commas separating the numbers, listing the numbers from least to greatest. The range of the same table would be -7, 0, 7, and 9. This relation would be considered a function because no two x coordinates are the same. For function notation, we write y now as f of x. X is the independent variable and y is the dependent variable because it depends on what we plug in for x. Let's do an example. For f of x equals -7x minus 10, evaluate f of x when x is -3. So if we do f of -3, we're going to substitute -3 any place that we see x. Okay. -7 times -3 is 21. 21 minus 10 is 11. So the solution to f of -3 when f of x is -7x minus 10 would be 11. On note card number 7, we covered linear equations and inequalities. The properties of an equality, if we use the variables a, b, and c, and those are all part of the set of real numbers, we have addition, subtraction, multiplication, and division. Whatever you do to one side of the equal sign, you must do to the other side of the equal sign. Same holds true for an inequality symbol. Let's do an example. If we're asked to solve 4x plus 9 equals -15 plus 2x, first thing we're going to do is subtract 2x from both sides, which gives us 2x plus 9 equals -15. Next, we're going to subtract 9 from both sides, which leaves us with 2x equaling negative 24. Our last step is divide both sides by 2 to get x equals negative 12. If we were asked to solve, 9 times 3 minus 2x equals 3 times negative 6x minus 5, first step we would do is distribute. The next step, we would add 18x to both sides. Because 27 does not equal negative 15, the answer to this equation is going to be an empty set represented by 2 braces with nothing in between them, or a 0 with a line through it, or no solution. Okay, if we had solved 7y minus 14 plus 14y equals negative 10 plus 21y minus 4. First we would combine like terms, which would give us 21y minus 14 equals 21y minus 14. If we subtract 21y from both sides, we're left with negative 14 equals negative 14. Since negative 14 does indeed equal negative 14, the answer to this would be all real numbers. For linear inequalities, you need to remember that the first symbol means is greater than, the next symbol means is greater than or equal to, the third symbol on the list there means is less than, and the last one means is less than or equal to. When you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. Let me show you why. Let's take the example of 3 is greater than 2. If we were to multiply both sides by negative 1, we'd get negative 3 and negative 2. If we were to leave the inequality symbol as greater than, we would have negative 3 is greater than negative 2, which is not true. Now if we switch the inequality symbol around, we have negative 3 is less than negative 2, which is true. So always make sure that when you multiply or divide by a negative number, you reverse the inequality symbol. Now if we were to graph on a number line an inequality, here's 2 different examples. We have x is less than negative 2 in purple. Because there's not a half of an equal sign underneath that inequality, we have an open circle at negative 2 heading to the left. An easy way to remember which direction it goes, as long as you have the variable followed by an inequality sign and then a number, the graph on the number line should go the same direction that the inequality symbol points. As you can see, x is less than negative 2 points to the left. Your line also goes to the left. On the other side, in green, we have x is greater than or equal to 1. Because we have greater than or equal to, we have a filled-in circle at 1. Because the inequality points to the right, our line is going to head to the right. Finally, on note card 7, we covered proportional reasoning. You need to recall that a ratio is a comparison of 2 numbers by division. A proportion is an equation stating that 2 ratios are equal. The cross products property, basically cross multiply and divide, for real numbers a, b, c, and d, as long as b is not 0 and d is not 0, okay, if a divided by b equals c divided by d, then multiplying a times d equals b times c. Finally, on this note card, you need to remember that percent is a ratio that means per 100. 40% is the same thing as saying 0.40,